In Miami, a major disaster leaves a nation in mourning.
The side of it was completely gone. It was the shock and the awe because you have no idea what just occurred.
In Canada, a gaping hole opens up in the middle of the nation's capital.
It was massive. It was water just rushing down here. It basically looked like you were looking inside of Niagara Falls.
In California, one of the world's most famous bridges is making a big noise.
There are reports from as far away as 8 miles. What is going on here?
And in the UK, an iconic London bridge in imminent danger of collapse.
There was nearly a riot on this side of the river. The impact was absolutely tremendous.
With big builds, even the smallest mistake can be a huge disaster. From miscalculations to misunderstandings, some with deadly consequences. These catastrophes are every engineer's worst nightmare. In everything they build, engineers must consider the relentless forces of nature. Any weakness can be exposed with devastating consequences. Like this disaster in Florida, a tragedy that struck a beachside community and made global headlines.
Champlain Towers, it collapsed.
A condo building that was devastated in the middle of the night.
I thought it was a storm. The ground shook. Thunder does not make the ground shake.
One of the deadliest catastrophes in American engineering history.
Some of the officers were actually in the garage trying to help people out. I'm amazed and proud of those 3 young men and what they did when they got here.
This building went straight down. I mean, it was just flattened.
The 4 unit, the 3 unit, the 2 unit, the 1 unit. If you were there that night, you didn't make it.
Miami, Florida, famed for endless golden sand, is also home to beachfront communities like Surfside. Wendy Rhodes is a local journalist.
This is the beach in Surfside right here. Surfside is a very small, quiet family community for people to come and just relax and enjoy the beautiful nature and beaches that Florida has to offer. It's really quite lovely.
Surrounded by sand and surf, an uninterrupted view is a must. To achieve that, builders use a technique known as flat slab construction. Structural and forensic engineer Joel Figueroa Valinas explains.
A flat slab structure is basically built out of columns and walls supporting floors. There's essentially no beams. It's a very simple, very quick method of construction, and there's no need to construct secondary walls. There's no need to construct additional elements. The integrity of the building is primarily relying on the connection between that column and that floor.
Effectively, the floor slabs are the beams. So steel reinforcement strengthening the slabs and connecting them to the columns is crucial to supporting a structure like this.
Built in 1981, Champlain Towers South was similar to many of the neighboring condos on the block. Former resident Steve Rosenthal enjoyed the elevated and vibrant 136-unit neighborhood.
It's a wonderful community, it really is. I knew all my neighbors, or most of them, in Champlain Towers. It's just beautiful and wonderful. I had the ocean as my background. It's everything you could want.
But in 2021, this tight-knit community's world was about to come crashing down in one of the deadliest disasters America has ever seen. Early morning on June the 24th, Steve Rosenthal was in bed in his 7th floor apartment.
It was about 1:15 in the morning. I heard the loudest thunderclap I ever heard in my life.
Surfside resident Nicholas Balboa was also having trouble sleeping.
I decided to take my dog out for a walk, and I heard this loud sound. At first I thought it was a storm, but then I heard it again, and this time the ground shook. Thunder does not make the ground shake.
This was no thunderstorm.
The bed began to shake. The room began to shake. I ran out of bed, go to the living room. Well, it's just all dust. Can't see anything.
Although Steve didn't know it yet, the whole center of his building had collapsed.
I go to the front door. I open up the door, and I get hit with a plume of smoke. Like a sonic boom, it just knocks me back.
Seconds later, the entire eastern side also came crashing down. Capturing the only known photograph from inside, Steve was now trapped in his 7th floor apartment.
Everything that's behind that rubble, all gone. And the destruction just stopped like 2 feet from my door.
Emergency services raced to the scene. Surfside Police Captain John Healy was among them.
We train all the time, and I don't think any training could prepare you for what you're about to see.
Some of his officers were already on site. Body cam caught their reactions.
Captain, hey, the Champlain Towers, the building, it collapsed.
The front of the building was still standing here, but the side of it was completely gone. It was the shock and the awe because you have no idea what just occurred.
55 of the 136 condo units had been reduced to rubble, leaving the rest of the tower potentially unstable. Fire Rescue Battalion Chief Brandon Webb knew time was against them.
The pool deck had collapsed into the garage. That exit wasn't there anymore, and the debris was blocking the door. So the only way out of the building was either from an upper floor by ladder or through the parking garage that was flooded and partially collapsed.
Some people, like 7th floor resident Steve Rosenthal, were trapped on their balconies.
The fire engine cherry picker is now rescuing people, starting with the corner units. Even when you're in the cherry picker, you're thinking, well, is the front of the building going to collapse on us?
While the fire rescue team was evacuating people from above, Captain Healy's officers were searching down below.
Hello? Where are you? Are you okay? What? Are you okay? Is anybody down there injured?
Some of the officers were actually in the garage trying to help people out. A portion of the building that was still standing but partially collapsed, trying to help people. So when I see that, I'm amazed and proud of the courage of those 3 young men.
We had gotten the people off the balconies, we had gotten the surface trap people out, but we had identified that there were still people in the building. We could see flashlights on the upper floors. They started their way up with fire crews, doing targeted searches of the remaining building.
As news of the tragedy quickly spread, journalists like Wendy Rhodes were stunned by what they saw.
It was a horror show. It literally looked like a dollhouse that had been split open, and you were looking inside the dollhouse with all the furniture.
Nicholas Balboa heard a boy crying for help. He quickly alerted the rescue team.
When we found him, he was in his PJs, right? You know, everybody knows what home is, right? That's where you're safe. And for it to just completely fall out from beneath you randomly in the middle of the night is just, I couldn't imagine. I absolutely couldn't imagine.
The boy was rescued, but sadly it was too late to help his mother.
I wish I could have done more, but you know, she didn't make it. To be 15, you know, he needed his mom still.
The search continued around the clock, but as the days went by, the odds were increasingly slim.
I knew it was bad news. I think everybody knew it was bad news. This building went straight down. I mean, it was just flattened. So we knew from the beginning that the odds of finding survivors was going to be pretty low.
After 32 days of searching the wreckage around the clock, the final victim's body was found. In total, 98 people had lost their lives in one of the worst construction disasters the US had ever witnessed.
They were my neighbors. Of the 98 that perished, I probably knew 60 of them for sure. The 11, the 10, the 9, the 4 unit, the 3 unit, the 2 unit, the 1 unit. If you were there that night, you didn't make it.
The world was watching and they wanted answers.
Everybody's question was, what happened? How could this have happened? What went wrong?
The National Institute of Standards and Technology, a federal agency with expertise in analyzing building failures, launched an immediate and far-reaching technical investigation. For experts like forensic structural engineer Joel Figueroa Valinas, the security camera footage was a major clue.
My first thought was, this has to be a flat slab building, and the reason for that is because of the way the collapse was very clean and vertical. It just came straight down. In flat slab construction, the joints of the slab connect the columns. One of the downsides is reduced redundancy. There's not a lot of belts and suspenders in that type of construction.
Just one failed connection with a column can be catastrophic.
Once one of those floors fails in their entirety, gravity takes over. So the building essentially comes down as fast as gravity can bring it down.
The type of structure explained the speed of the collapse. The big question was what had caused it to fail in the first place. Eyewitness accounts alerted engineers' suspicions to one area. Mehrdad Sassani is a professor of structural engineering.
Some people saw that the pool deck, which was the roof of the parking garage, collapsed a few minutes before the building collapsed.
Although not visible from the CCTV footage, a failure from below fits with the way the structure fell.
At the first view, one might think that the collapse started from the top, but the motion starts from the bottom and propagates up rather than starting from the top, propagating down.
Any failure in that pool deck or garage area would have potentially initiated a collapse, and it's dragging those elements down to the ground with those other elements that have already failed.
An earlier engineering report, released in 2018, had identified potential problems in the slabs between the pool deck and the garage. Soon after the collapse, footage emerged proving that water had been seeping into the reinforced concrete slabs, which were fundamental to the structure's strength.
Reinforced steel is great until water gets in. But once it starts to corrode, rust can expand the metal up to 7 times its original thickness, cracking the concrete in the process.
Which makes all of that reinforcement potentially deficient to carry the structural loads and even to stay interconnected with the other concrete elements.
Over time, if just one of those connections in the parking garage failed, it could lead to a phenomenon known as punching shear.
Punching shear failure occurs when the slab is overloaded and/or when the connections don't have enough strength.
Once one weakened column failed, the weight of the slab could have proved too much for its neighbors to bear.
The load that was carried by this column now needs to be carried by the surrounding columns. That transfer would lead to significant amount of horizontal force applied to the structure.
Those columns holding up the deck would essentially punch through the slab. Without any support, the next floor then drops and so on, causing what is known as a progressive collapse. This type of failure can come with practically no warning, and the results can be devastating.
But it may not have just been a leaky pool deck. Huge planters around the sides, many not on the original plans, were adding thousands of kilograms in extra weight.
So it could be overloaded. there is a balance between the load and the capacity.
The year before the disaster, there was evidence that concrete was crumbling away from the steel reinforcements. This could have been a warning that the extra weight was weakening this entire area.
Whatever the eventual outcome of the investigation, one thing is certain. This terrible tragedy shocked not just Miami, but the whole world. Ten days after the collapse, the surviving Western Tower was deemed unsafe and demolished. Residents living nearby began to question the structural integrity of their own buildings.
These people, they need answers. They need to know that they're safe in their own homes, and when they go to bed at night, their building isn't going to collapse.
Political leaders called for immediate inspections of other older condo complexes. And while the investigation is still ongoing, potential problems of any kind in any building have to be examined and dealt with.
If we as engineers are to learn anything from this, is that there are three main things to have a durable structure. One of them is design, the other is quality control during construction, and the third is maintenance. And if any of those are missing, then we should really revisit how we're doing this process.
And for the 98 Surfside residents who sadly lost their lives, their memories will never be forgotten.
I saw a side of humanity that I've never seen. And I hope I'm never in such a tragedy that I have to, see it again. I hope I can see it on a daily basis and that it doesn't take something this horrible to bring us together as one people.
You learn a lot about your friends and the community when a tragedy like this happens. People have stepped up for me, and life goes on. It has to.
When it comes to bridges, engineers are constantly striving to make them bigger, better, and stronger. But any change, no matter how small, can have unintended consequences. Like this story in California, a major safety upgrade that made a big noise.
If there's a problem, it's going to be far worse on a suspension bridge than on just about any other kind of structure.
One of the world's most famous bridges was blowing in the wind.
When it started howling, people clearly wanted to know why.
San Francisco, California, the city by the bay, is regularly voted as one of the most beautiful places on Earth. Gabe Moline is a local journalist.
Otis Redding in 1967 sat on a dock right over there in Sausalito and wrote "Sitting on the Dock of the Bay" while he was looking at this beautiful city right before him. I just think that's an incredible image.
For 80 years, this stunning cityscape has been dominated by the Golden Gate Bridge, one of the most famous structures on Earth.
The Golden Gate Bridge is easily the most iconic landmark in San Francisco. Everyone who visits here wants to see it, wants to walk across the bridge. It's photographed probably 1,000 times an hour, if not more. You can't imagine San Francisco without it.
Every year, 40 million vehicles cross the more than 2,700-meter-long bridge, while 10 million visitors flock just to see it.
These statistics are staggering. And if you attach all of the wires and the main cables end to end, they would stretch more than 3 times around the world.
And it was all to connect San Francisco with the north across the deep and wide Golden Gate Strait.
At its narrowest point, the channel is nearly 2 kilometers across and more than 100 meters deep. Add in earthquakes and high winds, and building a bridge here was one serious challenge for bridge engineers.
Dr. Stephen Ressler is a former US Army and civil engineer.
It
really was the deep water of the Golden Gate that required that the principal structural supports all be very close to the shoreline, and that a single long span would arc out across the body of water without any intermediate support down below. That was really an act of amazing vision.
Initially conceived in the 1870s, this vision took decades to become a reality, with construction finally starting in 1933.
So the Golden Gate Bridge opened in 1937. It took 4 years to build. At the time, it was the longest and tallest suspension bridge of its kind.
The bridge has been named as one of the wonders of the modern world by the American Society of Civil Engineers.
The vast bridge stands seemingly solid as a rock, but it depends on a constant, careful balance of forces.
This part of California is well known for earthquakes, but in addition, at the Golden Gate, the bridge was going to be subjected to tremendously powerful winds.
Despite the picture-perfect views, this location is hostile, so the Golden Gate was designed to withstand sustained winds up to 112 kilometers per hour.
I mean, just on the other side of us, it's all open ocean, it's the Pacific Ocean. And there's just a gigantic wind tunnel that comes right through, right across the bridge.
When the wind blows on a suspension bridge, particularly one that's very long and slender and thin, the tendency is for vibrations to begin occurring. Those vibrations sometimes are in an up and down mode like this. More dangerously, the vibrations can be in a torsional or twisting mode like this.
Thanks to major strengthening upgrades, the Golden Gate has endured storms for more than 8 decades.
It can get really, really windy across there. I've driven across that bridge when it's scary to drive across the bridge because you're just white-knuckling it on your steering wheel, you know, being kind of pushed around by the wind.
But in the summer of 2020, the bridge was at the eye of a very different type of storm. In early June, on a windy summer's day, local resident and musician Shirin Jafari was admiring the Golden Gate.
My family and I were actually walking by the Golden Gate Bridge, and we heard this beautiful sound of something like a didgeridoo. And we really thought that someone was playing an instrument.
But there was no instrument. Raymond Bergstrom Wood was out exercising.
I was biking up here, and the second I got to the bridge, it was just very loud. It's sort of like a whistle with multiple tones. I could tell that it was coming from the bridge, but not really where. In my eyes, it was like the Golden Gate Bridge was singing.
The strange sound soon started to spread across the internet.
I took a 1-minute video and I uploaded it, and it instantly went viral.
I took a video and posted it online. About an hour later, my phone was just exploding with response from all over the place.
There are reports from as far away as Daly City from people that can hear this sound. That's like 8 miles. It's kind of like, and I said to myself, how could this happen? What is going on here?
The noise was making world news, but at first its cause was a mystery.
This is one of the world's most famous bridges, so when it started howling, people clearly took notice and wanted to know why.
Although still standing very proud, the Golden Gate Bridge was now also very loud. It soon emerged that the howl resulted from a major safety upgrade program known as the Bridge Wind Retrofit.
The objective of this ongoing project was to improve the wind load resistance of the structure such that it would be capable of withstanding a 100-mile-per-hour wind at some time in the future. It's a good, logical, reasonable step to take to account for the ever-changing nature of our climate.
The job list included adding safety nets and streamlining the structure.
This bridge is so iconic, it feels like it's been there forever. But in the 1930s, this was at the very cutting edge of engineering knowledge. So any changes have to be very carefully thought through.
One key improvement was replacing the decades-old guardrail along the pavement. Professor of Engineering Abul Hassan Astanayasl explains.
So the old guardrail has very wide members. You can see these members here, and very small opening. So the whole area that is open is only 40% of area. 60% is solid, and wind puts a lot of pressure on that 60% solid. So they decided that let's take this out and put a new guardrail on the west side, which is much more open. So now the wind can pass through it and the wind pressure will drop.
The act of slimming down those vertical slats so that they present less area to the wind could actually have a fairly substantial effect on lessening the amount of force that the bridge feels in a heavy windstorm.
But this clever fix to protect the bridge turned out to be the source of the strange sounds.
When the wind passes through this new guardrail, now the wind is trapped with the roadway. And the top member, this handrail, has a very special curved, streamlined profile. So the combination of air getting into the bridge area and combined with this handrail profile is creating the sound that's very much similar to the sound of flute.
The drone left many wondering, should engineers have predicted the noise? Not so, says civil engineer Stephen Ressler.
Is it reasonable to expect that engineers who were designing a railing, purpose of which, in this case, was reducing the amount of wind force applied to the structure, is it really realistic or reasonable to expect that engineers would have looked beyond those principal purposes and asked the question, well, is this railing going to create an unusual sound?
With no signs of the sound stopping, in late summer 2020, bridge authorities announced that they were actively working to resolve the now famous drone.
Engineers have been wind tunnel testing to pinpoint exactly which bits of rail are making the noise. The hope is that the Golden Gate Bridge will once again be as quiet as it had been for the first 8 decades.
With the investigation still ongoing, the bridge's strange music continues to divide the critics.
There are certainly people that are very, very mad that they have to put up with this sound who live nearby. But there are some people who really like it. There are some people who harmonize along with it.
And when engineers do finally fix the drone, for some, the silence will be golden. With big infrastructure, engineers can dedicate years to just one project. But make just one mistake, and the consequences can be devastating. Like this story in Canada that struck at the heart of the nation's capital.
I was in shock. I was in awe. Everyone was fleeing.
A huge hole opens up in the middle of downtown Ottawa.
It was massive. It was water just rushing down here. It basically looked like you were looking inside of Niagara Falls.
One of the capital's most historic streets was on the brink of destruction.
Once the road started to go, nothing was going to stop it.
Ottawa, Canada, established on the banks of the Ottawa River, was a remote logging town before being hoisted to fame as the nation's capital in 1867. Stefan Keys is a local news anchor.
Ottawa has really come into its own from small lumber town to a city of 1 million people. Federal buildings and public servants and high tech, and we're really also very much an academic city as well.
A thriving capital city needs public transportation to match. But until 20 years ago, Ottawans depended almost exclusively on buses.
So there are actually lanes just dedicated to buses and roads dedicated just to the bus system. But it made the roads very congested.
In 2012, construction began on the new Confederation Line, an all-electric light railroad running east to west.
It was huge for the city. It was a game changer. We felt like we'd finally be like a Toronto or a London. We weren't just going to be this little small town that everyone forgets about.
For much of its length, the line would run on the old bus route, but in downtown, it would go underground.
So they dug very deep below ground, and it was going to go from east to west to start and open up in phases.
Large stretches of the tunnel were bored through solid limestone. But beneath Rideau Street, one of Ottawa's most historic roads, the ground was much softer. Kamal Hussain is an assistant professor of engineering.
Ottawa is built on soft ground. It's also called quick clay or Leda clay. So it's basically very unstable foundation material, and you don't know how far you will go to get a bedrock.
Normal clay is very sticky and holds together very well, but quick clay is much weaker and unstable. It can easily liquefy when wet, and is famous for causing landslides in countries from Norway and Russia to Canada.
Here, the clay filled a hidden underground valley and was a major headache for tunnelling.
Because the ground was so soft, engineers used a special technique to stabilise the tunnel walls. Essentially, they surrounded the earth they wanted to dig out with steel rods or pipes to help support the roof. It's known as a pipe umbrella.
Steel rods or pipes are driven forward into the soil around the intended tunnel section, like a long tunnel-shaped umbrella, working like a kind of skeleton to help support the roof when the material is removed. Despite the soft ground, by summer of 2016, work was well underway. Jeff Elliott's office was nearby.
This was going to be the first light rail transit underground train system in Ottawa, so people were excited about it. It was a big thing for the city.
On June the 8th, tunnelling was approaching the new station when Jeff got a surprise.
The power went out in the building, so I knew something was going on. So I grabbed my phone and went up to the rooftop. You could see from this area down here, the road was just gone.
The huge sinkhole was destroying Rideau Street.
The sinkhole immediately started to swell with water. I was in shock. I was in awe.
It was massive. Lots of water rushing through. It started right about here and then progressed down and eventually went right across to the other side of the street, where it ended up sucking in some of the light posts that were here.
The growing hole swallowed a minivan, slicing Rideau Street in two.
The hole didn't just take down the road, it broke water pipes and electricity cables, as well as rupturing the gas main, which risked triggering an explosion. So nearby buildings had to be evacuated.
All the buses that were usually going down here had to be rerouted to another street. And then in addition to that, the intersection behind us here was also blocked off, so anybody trying to come down through the main core here had to find alternate routes.
Ottawa and its light rail project were in chaos.
Everyone was looking forward to this. It had been a long time coming, but before we even had a chance to see what the train would look like, then there's this major engineering question mark. This was big for the city.
People were shocked. They wanted to know what was going on in the middle of downtown Ottawa, how something like this could happen.
The first suspect was the gushing water main, but investigators ruled that out as the result of the collapse, not the cause. It seems the problem was the clay-filled valley, which was saturated with groundwater and weaker than expected. Engineer Kamal Hussain explains.
I'm demonstrating how water can destabilize different type of soil. So I'm pouring water into the soil sample. You can see how the sand cone is spreading all over the ball and it became destabilized. With the rain and surface runoff, the water can erode that soft soil. That erosion creates gaps. This gap can eventually turn into sinkhole.
Although the pipe umbrella system helped stabilise the ground, it just wasn't enough to prevent the saturated quick clay from slipping between the rods into the tunnel below. That opened up a massive void beneath the road, and the rest is history.
The dramatic collapse occurred on June the 8th, but with Canada Day just 3 weeks off, the road had to be fixed and fast.
Luckily, no one was really injured in that incident. They drained all the water out the best they could, and they just started filling it. They started filling it with asphalt, piling on, then cement on top.
The minivan couldn't be salvaged, so it was left inside the crater, while workers filled the hole with concrete and reconstructed the road above. Finally, in September 2019, 3 years after the disaster, Rideau Station opened to passengers, and Ottawa was fully on the move once more.
It was like Ottawa residents were winning the lottery. They couldn't wait to hop on this thing and ride it.
In big engineering, careful maintenance can be just as crucial as construction, because sometimes lurking within, a minor problem can become a major catastrophe. Like this bridge in the UK, a historic crossing in danger of imminent collapse.
The impact was absolutely tremendous. It was devastating.
Potential disaster lying hidden in plain sight.
Corrosion had gone unchecked for decades, putting the entire structure at serious risk.
One of London's most famous bridges could have fallen down.
The city couldn't take any chances. They had to shut it down fast.
London, England's capital, was founded as a small town back in Roman times and expanded along the banks of the River Thames, which is the beating heart of the city.
Some of London's most historic buildings are situated on or around the River Thames, not least the 35 bridges that cross it, some amongst the most famous in the world.
And one of London's most eye-catching, lying around 10 kilometres west of downtown, is this, the Hammersmith Bridge.
Morning, Captain.
As Keith Whitehouse, chair of the local Historical Society, explains, when it opened, it caused quite the stir.
Hammersmith Bridge was built in 1887. It was the first suspension bridge on the Thames, and when it opened, there was hordes of people turned up, royalty, dignitaries, to make a big splash of it.
Not only is this bridge unique in London, it's the only one of its kind in the whole of the UK.
The bridge is more than 200 metres long, with ornate iron towers sitting on concrete piers below. But what really made it stand out from the bridge crowd was that it was all connected with these massive eye bars.
Here, instead of cables, a series of eye bars were used as the main supporting elements, essentially like a giant bicycle chain attached to the large cast iron pedestals that hold the whole structure in place.
This historic crossing is aptly known as an eye bar suspension bridge, with each end of the eye bar chain sitting on roller bearings at the pedestals.
The steel roller bearings allow the bridge to move horizontally under heavy loads, reducing the stresses on the towers.
For more than a century, it's been a big hit with Londoners like local resident Jane Bain.
It's so iconic. I love the bridge. I think it's wonderful. I can't imagine not waking up every morning and looking out of the window and seeing the bridge there. It's just magical.
But while the bridge may be magical, a problem lying hidden inside put it in danger of disappearing forever. After more than 130 years of standing proud over the Thames, Hammersmith Bridge was struggling to cope with the rigours of modern life.
The bridge was originally designed for horse and carts, so even far-sighted engineers couldn't have predicted that it would have to cope with over 20,000 vehicles a day.
Council was due to repair it, but they did a much more thorough structural survey using modern technology. They discovered there were some cracks in the pedestal, so for safety reasons they decided to close it to traffic.
While still open to pedestrians, around a year later, a much bigger problem was found that could have closed the bridge for good. New sensors inside the bridge alerted engineers to a rapid and sudden increase in the size of the cracks in the cast iron pedestals that were essential to the integrity of the entire bridge.
Engineers believed there was a clear and present danger to pedestrians and cyclists and immediately closed the bridge.
At 5 p.m. on August the 13th, 2020, without warning, the 133-year-old bridge was completely shut down.
There were people that had come across the river and couldn't get back home again.
Rush hour commuters were stranded and tempers were rising.
There was nearly a riot on this side of the river. Hammersmith had to send marshals out saying to people, look, I'm sorry, but you can't cross.
With around 16,000 pedestrians walking across and hundreds of boats travelling under this bridge every day, authorities weren't about to take any chances.
While there's no way of knowing for sure, local politicians believe that by closing it down, they averted a potential catastrophe in the capital city.
Some believe the cracks may have been caused by a process known as dynamic loading. Professor of Engineering Armawadi explains.
The dynamic load arises from the repetitive loading of the traffic. A lorry comes over the bridge, you have a high stress in certain regions, it leaves the bridge, and then suddenly the load is completely changed. And so you have a lower stress in a particular part of the bridge. Over time, this loading repeats, and so the stresses on the bridge go higher, they go lower, they go higher and lower, and so on. But over time can actually cause fatigue cracks to open up.
An inspection found that the bridge was also suffering from corrosion that had been ongoing for nearly 7 decades. The roller bearings, vital to the bridge's flexibility, had corroded and seized up, meaning the bridge was having to cope with much more force than it was ever designed for, causing cracks in the pedestals known as microfractures.
Microfractures can indeed be catastrophic. If the cracks open up and cause fracture of the local abutment, then this may change quite considerably the way that the forces and stresses are transferred from the deck to the foundation. And this may compromise other parts of the bridge which may not have been compromised initially.
And with cast iron, cracking can be a serious problem.
Cast iron is brittle and can shatter, so although these fractures were tiny, there was a serious concern that the bridge could collapse into the River Thames.
A government task force was set up to find a solution for this historic crossing. Still in the early stages, the long-term plan is to fully restore, repair and reopen the bridge to both pedestrians and traffic by 2027. Just 11 months after first closing, it was declared safe enough for pedestrians and cyclists.
When the bridge reopened, it was absolutely magical. I was just so happy. Went up there, it was so nice. Such a happy day.
While it won't be cheap, with some estimates topping £100 million, many think it's well worth the effort.
As well as preserving this treasured bridge for generations to come, ultimately this is about safety, no matter how long it takes. And as engineers often say, the devil is always in the detail.